Good morning, West Coast. Good afternoon, East Coast, and welcome to the Fibre Channel Industry Association webcast today for Fibre Channel Interoperability. I am your moderator, David Rogers from Teledyne LaCroix. With us today will also be our friends from HPE, Barry Maskus and Tim Sheehan. A little bit about the FCIA, Fibre Channel Industry Association industry group for the benefit of Fibre Channel. We're a nonprofit, and we focus on advancing the specifications of Fibre Channel and working to ensure interoperability across the platform, hence today's webinar. As I said, I'm David Rogers. I'm with Teledyne LaCroix, and I'm on the board of directors for the FCIA. Our speakers today will be Tim Sheehan. Tim's with the UNH Interoperability Lab, a senior engineer, and focuses on Fibre Channel and NVMe solutions testing. And with us also from HPE, and our storage network consultant and one of the leaders of our Fibre Channel industry is Barry Maskus. These two gentlemen will be providing us some content. I'll be taking your questions and helping them understand, or helping give them the questions and keeping them on track, I think. This is our agenda today. It's a brief history of our interoperability, standards and conformance and interoperability, the FCIA-sponsored Plugfest events, talk about systems interoperability and systems compatibility, the FC ports and the importance of NPV and NPIV, the dimensions of interoperability, a summary, and then some Q&A. So with that, I'll hand this off to Barry Maskus from HPE. Barry, go ahead.
No, Tim's first.
Oh, in that case, I'll hand it off to Tim first, along with the rest of today. Tim, go ahead. Sorry.
Great. Thank you, David, and hello, everyone, and thank you for listening in on this FCIA Interoperability webcast. As David said, we'd like to discuss interoperability with respect to the Fibre Channel transport technology. My name is Tim Sheehan, and I'm a senior engineer at the University of New Hampshire's Interoperability Laboratory. And, you know, the UNH-IOL was actually first created due to interoperability back in 1988. Two UNH professors received a grant to work with and test two token ring devices that were both written to the most current token ring standards of that day. And when they connected them up into an interoperability fashion, well, what do you know, they didn't work. And the lab was born. So, for as long as networking devices have been around, there's always been a need for interoperability. And simple interoperability testing, you know, created the lab here at UNH-IOL, but it's important today across all industries and all networking devices. Okay. Here's a basic definition of interoperability. And of course, without the capabilities, Fibre Channel, the whole Fibre Channel industry would not have had the success that it's had over the last 20 years. Now, there are obviously different kinds of testing that happen out in industry, in different companies, in different labs. There's unit tests of individual devices. There's system tests of integrated systems. There's conformance tests, which verifies that devices meet the standards defined in standards. There's also performance testing that measures the effectiveness of items such as speed. And then, of course, you've got interoperability, which is the type of testing to check if a set of products can interoperate with each other. This is what we're going to focus on today, although we'll touch on a couple of the others just for the discussion. And of course, there is an order to how the testing happens. Okay. So today, we're going to talk about interoperability, but one of the first things that needs to happen before we do interoperability testing is usually devices are developed or products are developed to a conformance to a standard. And conforming to Fibre Channel standards gives a good starting point for interoperability testing. It allows different products to be created with similar functionality so that they could actually perform interoperability if they were connected up together. But as the story of the IOL shows that I just explained to you guys, interop testing is still an essential part of any product's testing process. Today, there are at least 4 levels or layers in the Fibre Channel stack. This stack is similar, if you were to think of it as similar to the OSI level stack, and we'll talk a little bit more about this later. Okay, this next slide is kind of an eye chart, but what it really does is anybody who's on this webcast now or downloads it in the future would be able to see all of the different standards that are happening and coming and being developed out of the T11.org body, which develops many of the fiber channel standards. The asterisks that you see next to these standards, these are the actual standards that are under development today. So when you download these slides, you'll be able to get a good understanding of the efforts that are happening within the T11 and also with the FCIA organization. But what I'd like to talk about for a little bit right now is just to talk about the different layers and how interoperability plays into each of them. As I said, there are 4 different layers of the fiber channel stack, and these are all different functional layers that handle different parts of the fiber channel transport protocol. The diagram on the right shows the OSI stack that I had mentioned earlier, and also how it equates to the fiber channel stack and also the fiber channel over Ethernet stack. You know, throughout fiber channel's history, a large amount of conformance and interoperability testing has happened to make each one of these layers, you know, work correctly. So you start off with the FC0 level, which is going to handle a lot of the physical media. FC1 handles, that layer will handle transmission protocols, data link layers, and encoding and decoding of signals. And then FC2 will go on to handle many of the IUs, exchanges, and port-to-port connections. FC3 is a common services layer like generic services, but also handles other features. And FC4, this is probably the most important to the end customer who uses fiber channel products, because this is the one that actually moves data and actually stores the information from one location to another. So each one of these layers are very intricate, and what we're going to touch upon today are just a couple facets of each one of these. We won't get into detail on each one. Obviously, you can read the standards to find those out, but I'll try to give you an idea of why interoperability, you know, is important with each one of these. So, FC0 testing. Here are a few of the areas that, as we mentioned, would happen with, you know, that are included within the FC0 level or layer of the fiber channel stack. You're going to be testing out a lot of the physical elements, this is your optical cabling, your transceivers, and connectors and things like this. Obviously, your electrical is better for short distances, and your optical, you've got a couple of different flavors there. But that's an idea of at least what happens at this layer of the actual FC stack. Now, a couple of things that are going to happen at this layer is you're going to test out transmitter and receiver functions and data rates. You're going to have some of the characteristics that you're going to make sure are actually documented inside standards are things like for jitter or acceptable bit error rate or BER. You would also have things like signal amplitude. So the standards would actually lay out or dictate that some of these particular parameters should be set at certain levels, and that would be called the conformance part, that you're making sure that your device conforms to those actual shells within a standard. But the next part is okay, your device might actually conform to those standards, but maybe your device is right on the edge of one of those standards. Maybe your amplitude is just a little, you know, it's within the actual standard, but it's very close to that edge. And when you hook this up in an interoperability fashion to another device, something is lost over that line, you lose some of that amplitude, and you would not be able to interoperate. That's why interoperability at this level is important. Now, what I'd like to do when I talk about each one of these layers is talk about how we would actually do a fabric login, which is called a floggy, F-L-O-G-I. That's a floggy. And a floggy allows you to actually log into a fabric so that you can actually move data from one point to another. Now, we would not be able to, if you were not able to interoperate at FC0, you would not be able to, you would have too many errors on the line, or you didn't have a strong enough signal, or maybe it was just jittery enough that you couldn't get a good link, and you wouldn't be able to move any traffic or any frames, and we would not be able to floggy at this point if we did not have good interoperability and good conformance to the standards coming out of standards bodies. As we move along, up the stack a little bit more, we are now at the FC1 level. This level now is actually responsible for the encoding and decoding at transmission and reception points from your endpoints, and allows for synchronization, data recovery, and running disparity. Now, you also start talking about frames, and a lot of information, or all information, is actually passed in Fibre Channel through Fibre Channel frames. And you also start dealing with some of the link level protocols, such as being able to handle state machines. Now again, conformance in the standards will tell you that you need to be able to do all of these things at certain times, at certain levels, and making sure that you can actually interoperate with somebody. But again, if you're not able to achieve synchronization or encode or decode based off of the different types of encoding that you have, then you would not, again, be able to communicate. Even though you might be able to have the link up and running correctly, it would not actually be able to sync the clocks on both ends, on the decoder and the encoder, and you would not be able to move any traffic. So again, this is some of the areas that you're really going to want to make sure that you're able to do within terms of interoperability testings. And if any of these functions don't operate, like I said, you're going to have an unstable connection. And again, if it doesn't work, we're not going to be able to floggy into the fabric. If it all works, then great, we can move on to the next level, up the stack a little bit more. And the next part of the stack, of the FCI stack, FC stack, sorry, is the FC2 level, which is the control and management for delivering of information. So now we've got a link, we've got some means to control the link and actually send frames, and we're going to start looking at frame formats and creating different kinds of frames to control Fibre Channel data, or the transport of Fibre Channel frames that would then present the data to the endpoints. Okay, on this side, at this level, you would have different kinds of management sessions. You'd start talking about combining frames into exchanges, sequences, and information units, or IUs. These are all areas that are handled by the FC2 layer, and again, another essential building block of the FC stack. Now, when we want to make sure that interoperability works correctly here, because if you get out-of-order packets in any of the IUs or any of the exchanges or sequences, then that could be bad. And as we all know, data integrity is the hallmark of Fibre Channel. And interoperability, once you've got all your encoding and decoding and your packaging of frames, and you've got all of your exchanges and sequences all up and running correctly, then making sure that that works between two separate devices is integral. You want to make sure at this point that you can actually send frames, and you should be able to. As long as you've done the correct amount of testing at the layers below this FC2 level, and you've also done it correctly at this FC2 level, then at this point you should be able to send a floggy, but at this point nobody knows what a floggy is, because really a floggy is to, as we said earlier in one of the slides, it's to actually log into a fabric. And the next levels that come up in the Fibre Channel stack is FC3 and 4. Now, FC3 is typically, or been talked about as generic services interoperability, and generic services were created such that you could use them in a fabric topology. Generic services, they are a set of Fibre Channel services that allow for that expansion of FC point-to-point connections and expand into fabrics or storage area networks, or SANs, and interop between these fabric devices and endpoints. And FC4 level, this is now where you start talking about upper level protocols or the actual storage level protocols that get transported over Fibre Channel, such as FICON, SCSI, or even the newest, latest, and greatest NVMe. Okay. So, again, at this point, we do have a fabric, so we would be able to log in with that floggy because we have a generic services, and one of the generic services is a login server that would be able to handle that floggy. So as we've built up through the levels of the Fibre Channel stack, you're now able to actually do what you want to do, which is create SANs that basically give you scalability to create a large fabric of network devices to store all the data you want. It's not just point-to-point, it is a complete fabric. And that's the important thing. But along the way, the thing to stress here is that, yes, you've had to do different kinds of testing, such as unit testing and conformance testing, but interoperability is definitely an important part of that testing sequence, because without interoperability, yes, your product can work with yourself or in a standalone environment, but in order to actually put it into a sand or a fabric, then you're going to need to make sure, or have it work with another product, you're going to need to make sure that it does work with those other products, and that's going to be interoperability. Now, some of the newer technologies, like I said, with NVMe and things like this is promising with the latest SSD storage, promises low latency, increased performance, and evolutionary steps for SANs. And I think Fibre Channel, because of all the testing that's happened over the years with all of these different levels and also the newer functionalities that have happened, Fibre Channel is well positioned to handle this new technology. Now, if you were to try to do interoperability or conformance without interoperability, as I said, it probably isn't going to, it could work, it definitely could work, because you could fall within the standards well enough that you would be able to connect to other devices. But as I said, if your product is just on the edge of one of those conformance standards, then you probably are going to have issues when you actually conform or try to interoperate with another product. The latest NVMe, FC-NVMe specifications have done a great job of defining basic functionality that you can use in order to bind things like this. But again, NVMe is just that one standard, and throughout all of the testing you do for NVMe or Fibre Channel, you're going to need to go through interop testing, conformance, unit, system testing in order to do all this. But interoperability allows you to get to the point where you can perform your systems testing. Without a unit, without a conformance, then you would not have a product at all, but without interoperability, you wouldn't be able to network that product. So through the example that I used in Floggy, you can see that you need to build up and perform interoperability testing along with the other kinds of testing in order to make sure you can actually connect and work with other products. Okay. And again, once you've gone through unit and conformance testing and interoperability testing, now what this allows you to do is actually do a larger interoperability testing. This allows you to increase the number of products in your topology, in your fabric, and make sure that each of those can actually conform not only at the Fibre Channel transport layers, but also at those upper level protocols such as NVMe, SCSI, to make sure that you actually can conform and interoperate at those levels too. And again, one of the best places you can do this is Plugfest. Now, we've been having Plugfest with the FCIA for close to 20 years, and also with all the companies that are part of the FCIA. Typically, these happen a couple times a year, and it's a chance for all the companies in the Fibre Channel industry to come together and actually test out the latest and greatest functionality that's being developed, either in Fibre Channel or being Fibre Channel used as a transport. And NVMe, again, is the perfect example of this. It allows the chance to actually resolve any issues, make sure that you can interoperate with everybody who comes to the events, and also make sure that you can all check and create those latest products and determine any interop issues or debug issues along the way and potentially resolve them also. And now with a little more on interoperability standards and Fibre Channel, here's Barry Maskus from HPE. Barry?
Good afternoon, everyone. As Tim just explained, Plugfests are a great way to demonstrate your latest product development capability. And we just recently completed our fourth NVMe-focused Plugfest. As you see, we brought together a broad cross-section of the industry. And by the way, this is the companies have to pay in order to bring their equipment and their people to operate the equipment into this environment. You could think of it as a flash mob, right? We have a week to get together and we build up a big SAN and we Plugfest because we care about interoperability. And the earlier you can in the product development cycle demonstrate interoperability, the more stable you can show that the technology is becoming. And you know, at this fourth NVMe focused. Not only did we Plugfest at 32 GFC, which is the latest speed technology, but we also demonstrated some major accomplishments in terms of building up a SAN that's operating with fiber channel and FCNBME with what we call commercially available targets. So previous to this, we were using emulated targets, but at this fourth Plugfest, we had two of our major storage providers in the fiber channel industry bring their storage devices, and we were able to demonstrate their interoperability with fabric switches, with multi-hop fabric switches, with all of the initiator servers, and we also had a very interesting addition where, as some of you may know, blade servers pervasively use FCOE in order to get from the adapter on the blade out to a what you might call an aggregation device, or a blade switch is often used to describe it. But NVMe over FCOE, this was the first time it had been demonstrated. And so Plugfests are also used for proof of concept. And we had one very strong blade server provider in the industry demonstrate an ability to transport NVMe over FCOE through his blade chassis and out to our fabric that was operating with FCNBME and fiber channel. And finally, again, as a proof of concept, we successfully demonstrated that fiber channel AOCs are interoperable and can be a good technology to bring into fiber channel. At Plugfest, I just wanted to quickly give you a quick view. You know, we start off on the Monday morning of the Plugfest week. You know, we're all thrown into a room. We all have a purpose. We all work together. It's not a competition. It's a interoperability Plugfest. But we start off with very simple technology demonstration. Can I, as Tim pointed out, can I link? Can I log in? Can I move some data with integrity? Right? And so we start with a point-to-point connection. We add a switch, a server, and a target, and then we start to add multi-paths, right? And we do this incrementally, and we keep track of what works and what doesn't work, and sometimes we fix things in real time. And throughout the week, we just keep adding and building and adding and building and analyzing and checking data integrity and validating resiliency, right? So we pull cables, we reboot switches, we reboot storage targets, we reboot servers. But at the end of the week, we end up with what we call a large fabric build. It's a multi-hop, multi-target, multi-initiator, multi-generational, multi-protocol fabric, and we look for stability. And how do we look? We use analyzers, and there are some well-known providers of logic analyzers in the industry, and we locate them in a strategic place on the ISLs of the switches, and we have fabric visibility. And we look for errors, you know, aborts. We look for all the common fiber channel issues. And when there are issues, you know, you have a whole room of industry experts at your disposal to help you resolve these problems. And at this fourth Plugfest, we actually had a very interesting one, and we were able to bring in some high-level tools, exchange-based analysis tools that could look across the whole multi-vendor fabric and pinpoint certain behaviors and then we were able to take those behaviors back and find an issue and resolve that issue and, finish up the week on a very good standing. And so we had a press release last week saying that, the FC-NBME standard has reached a level of maturity. And by that, we're saying we are interoperable. We can perform all of the NVMe functions. We can perform it in the context of an existing fiber channel fabric, and it's stable. So it's a very strong feedback to the T11 committee and the FCIA that we sort of reached a plateau, right? And which is good because now we're working on FCNBME 2, which is called enhanced air recovery. The point being that standards evolve. Standards aren't a static thing, right? And fiber channel is not a static thing. It's not an old crusty technology that's, meant for the back room. It's modernized, it's refreshed, it's constant. Tim showed you how many standards are open and being developed. Now I want to move on and just take a little step back and talk about, at a functional level, we need fiber channel ports, and the port behaviors are strictly defined in the standards. And interoperability is afforded by the fact that we are able to define a port and define the functions of that port. And so when an end port device, a server, tries to connect to a switch or an F port, what is expected is detailed in the standard. And the standards strictly adhere to what can be accomplished through this port level connection, an N port to an F port, an E port to an E port, and then, to complete the end-to-end story, a server to a target, right, through a switch or a multi-hop link. So the key here is that the N port is the end device. The F port is usually the fabric or the switch device. The E port allows fabric devices to interconnect, and an N port is an end device.
Barry, let me bump in for just a second. We had a question from the audience that relative to who were the storage vendors that participated in our Plugfest, and if I'm not mistaken, that information is still covered by our confidentiality of the event. So we can infer from the list of vendors.
It is in the press release, and yes, we are, by the way, under an NDA. So details are kept within the community. But you can read the press release. The company names are there. You can infer who was the storage suppliers just from the name. They're well known, by the way. So, is that okay, Dave?
Thank you, Barry. That's exactly what that's exactly the answer. Thank you, sir.
Okay. So I wanted to talk a little bit about, NPV access gateway. One vendor will call it an NPV device, another vendor will call it an access gateway. This technology allows us to interoperate in a vendor-neutral way. Now, NPV is described in the standards. It's a virtualizer technology, but more importantly, it's used as a proxy technology. A device that is an NPV device will proxy some minimal set of fabric services to a fabric controller. Where this technology is used quite pervasively is in blade servers. Blade servers have a farm of servers connected through a common interconnect. That common interconnect is more often than not an NPV device, an aggregation device that proxies services up to a fabric controller. And that allows all of the servers to share an interconnect and get login and get zoned and managed at the fabric level, but their services are proxied through a medium or through an interim device. Why is that important? Well, it's important because we want to talk about, as Tim mentioned, higher level functions, right? So it is important to be able to have a multi-vendor capability, right? And in order to support multi-vendor interconnectivity, NPV is the sort of method that is used. And just wanted to point out there's a right way to use NPV and there's a wrong way. The right way is on the right, where you have your storage on the Fabric device, not on the NPV aggregator device. The reason being because that NPV device has to proxy the Fabric services at the name service, and you don't want all of your traffic having to make multiple traverses of links in order for you to accomplish a simple read, right? It's going to slow you down, it's going to add overhead, add latency, and limit your bandwidth. So there is a right way and a wrong way, and I personally have experienced customers who do it the wrong way and have problems, and we straighten them out, and things are good. So I want to just quickly define a couple of terms here. Compliance is something that you can measure. It's in accordance with the standard. Conformance is synonymous with compliance. And then compatibility, this is an area where I'd like to explain that standards create a platform. They have a language which says, you know, you shall or you should do something, right? But it doesn't inhibit vendors in the industry from being innovative and adding features, adding what we call value to the fiber channel solution, right? But it is incumbent on everybody, if they add these solutions, that they maintain data integrity, because the most trusted thing in fiber channel is the data availability and integrity. You know, so fiber channel is well known and it's trusted because we have compliance, conformance, and compatibility. There's a model for interoperability, and as I illustrate here, you know, it is a multi-hop fabric with multiple targets, multiple initiators, and it does use NPV technology or access gateway technology in order to have what we call vendor neutral fabric interconnect. And that is why I wanted you to understand NPV as a solution if you need to be a multi-vendor fabric. So the point is that almost every company in this business of fiber channel publishes a very long document sometimes, but their interoperability, their test results are published, okay? And, you know, there are some well-known eLabs and, you know, Brocade FOSS compatibility. All of these are public documents. Cisco Fabric Services interoperability. So what you start to understand is that this whole problem of interoperability is quite complicated. There are so many different things, right? You have software version 1 to software version 2 on the same appliance or device. Then you have that device interoperating with another device who also has their revision matrix, right? So we do interoperability because sometimes we introduce new features and functions and capabilities, right, that are standards-based, but not every device has implemented them at some point in time. So one vendor may be ahead of another vendor in terms of implementing a certain aspect of the standard, right? So we create guidelines, or we create interoperability matrices. And as you see, you know, HPE has its SPOC, which is called a single point of connectivity knowledge, right, where we document all of the interoperability testing. Atto has their interoperability matrix. VMware has a very large interoperability matrix, right? And there's so many different products within VMware, you know, orchestration and management and storage systems and you know, migration and so many different things. All of those have compatibility matrices. The point being, as a customer, you have information available to you to make objective decisions about how you want to put together a SAN. And again, it's built up from conformance and interoperability. It's documented, it's published, and everybody in this industry has their own version of that. Now, that version is built on standards. Standards have a very strict language, and that language is a shall. So Tim had mentioned link, login, and flogi, right? If the shalls were not adhered to and conformant, those three basic steps of fiber channel interoperability would not be successful. So every vendor has to or shall implement parts of the standard, and that is not questionable, and it's measurable. And so now we have companies that come into the industry who don't create original equipment, but they create the service of verifying the interoperability, right? They can write a test plan based on what shall be done, and there's a quantifiable, measurable, observable entity there in the shalls that are extracted from the standard. Standards are publicly available, and you can write a test procedure. You can put an analyzer on something and observe the frames and have some wizard or some software application check it against the shalls and score you on how well you're doing against conformance, which, as Tim pointed out, it underlies interoperability. If you don't adhere to the shalls, you will not have interoperability, right? So now there's another part of the standards which can be thought of as recommendations or shoulds, right? Here's, you shall do the following, but you should, for example, if an error occurs, you should do the following, right? But there's also a part of that error that says you shall, you shall send an abort, you shall retire that OXID. There are some definite shalls, but then there are some shoulds, right? And that should enables the industry to be innovative, right? And it does create varied implementations. It allows the implementer to make some of his own decisions on how things should be done. And sometimes in the standards we get some can, I can operate this way, or I can operate that way, or I will operate that way in a certain point in time if you enable a certain mode bit, or if you install a certain upgrade to your driver, or, so this language also gets into the standards, but it's not meant to be restrictive. It's meant to give guidance, and it's meant to enable innovation. And as you can see, if you look at Fibre Channel, it has more than 20 years of constant innovation, and it's constantly moving forward. And it's verifiable as it moves forward, right? So we like to think of standards as interoperability building blocks. The shoulds and the shalls enable solutions to be developed and to be validated by third-party integrators, testers, and solution providers who can offer system-level solutions that, function as expected. And then we have people who provide tools to the industry. And another thing that happens at a Plugfest, by the way, is tool developers such as Viavi and Teledyne LaCroix and Spirent or others can demonstrate their tools actually work correctly. And so it's a way to shake out new tools. For example, FCNBME, the decoding of all the information. You know, that's a software program, and that program has to be sanitized in a real fabric. And so Plugfests are an early way for tool providers to check out, you know, their latest tools, as well as help us mature the technology, so that, you know, down the road when you're in deployment or when you're doing interoperability testing, you can bring these tools in and know that they're giving you some straightforward information. You're not the test vehicle for validating tools. So third-party conformance testing has a big advantage in the industry, right? There are independent, industry-vetted, cost-effective. They benefit the vendor and the end user, right? Because if you can get a report from, say, the IOL that says all this equipment is interoperable, that's a fairly credible document, right? That says at this point in time when the devices were tested, they passed the tests, right? It gives you a building block to step up on. You know, it helps also to reduce costs, right? Because if you, as a customer trying to deploy a new SAN, if you had to do all this interoperability testing on your own, if you didn't have a published document, if you didn't know the pieces that were interoperable, and you just threw stuff together, you can imagine how costly it might become, right? So the industry, and this is why we all get together and why we have a common purpose in the FCIA and in fiber channel industry, this benefits the customer who can deploy this technology with a level of confidence that we provide through interoperability testing and published documents. And it allows selection, right? It allows the customer, empowers the customer to pick and choose things that are more interesting for his solution, you know, and sometimes if lock-in is a major concern, you can pick solutions that can avoid lock-in at certain devices, end devices, fabric capabilities, etc. But the point is, these solutions are trusted, and they're trusted through interoperability testing and conformance, which underlies interoperability. Another point here is that there's generational interoperability built into Fibre Channel. All of you are probably aware that 32 gig, 16 gig, and 8 gig are interoperable, and the standards actually specify, you know, there's a shall operate within 3 generations. Now, some vendors choose to do 4 and 5 because there's a should there that says, you know, if you want to, you can support more speeds as long as you can figure out how to, you know, do the negotiation. The shalls, you know, limit the scope for a good reason, because it's a complicated problem. And, you know, end devices can operate in a upgraded fabric from, you know, 8 gig working in a 32 gig fabric is fine, right? There have been advancements in tools to help you understand that sometimes a slow device, a legacy device, can affect the whole fabric. But now with enhancements in the Fibre Channel standards for quality of service and prioritization, we can actually dynamically, you know, drop slow performers to a lower priority and give, you know, sort of the fast lane folks a higher priority. And so this is a way that the innovation in Fibre Channel continues to make the solution more robust in multi-generational dimensions. you know, this whole realm of interoperability is quite complicated when you start looking at from the physical layer all the way up to these very customized SAN orchestration applications, SAN monitoring applications through standardized interfaces. You know, so there are SIM providers, SNMP providers. There, you know, many third-party tools are able to run on a SAN fabric and provide useful information, right? Some are free. Some have, you know, sort of tiered service, pay for certain more sophisticated analysis and services. But basically, there are public and private MIBs on this equipment to give you information. One more recent innovation is, why don't you put a database in the switch, the fabric switch, and register everybody's capabilities? So, you know, this whole idea of an FDMI database that's available, and all your end devices register their firmware version, what name they are, you know, what driver rev they're running, and what equipment they are, and what their capabilities are. You know, those kind of things, if taken advantage of, again in the should realm, allow tools that don't have to go search the whole fabric to get information, right? There's a central place for a tool, and he can get a lot of information that can help you understand that, hey, your server's out of date. You know, I can go back to my interoperability matrix, and I can say, you know, revision 6 of the firmware should be interoperable with revision 4 of the firmware of this other device. You know, and we can do checks, and we can do automation and scoring of, you know, your fabric based on interoperability. So again, what I did was since there are big databases out there, you can actually mine these databases and get an interesting perspective. And I did a radar chart here to basically show that from an 8 gig HBA view of the world to a 32 gig HBA view of the world, okay, there are far fewer interoperability dimensions of things, right? The playing field, so to speak, was much larger. In fact, several times larger when we had 8 gig devices and many different suppliers of 8 gig interoperable devices, and software applications and operating systems and storage appliances and storage devices and you know, management software, and of course the speeds is also part of that equation. But the point is, as we get into 32 gig fiber channel, the number of cross points illustrated by the areas colored in blue, right? The problem dimension is more tenable, right? It's not as complex. It's getting less complex in order to go through the full regression test of an interoperability matrix, and it's actually still quite complicated back in the 8 gig arena, and so the good news is the problem and the solution space is getting better controlled and getting more selective. This is just the, if you break down the radar chart into categories and you were to mine those categories, the point being of this, that you can look at interoperability through many different dimensions. You can take an operating system view. You can take a path management view, right? It's unbelievable, but there are over 126 path management solutions in the industry, right? And interoperability across them has to be well documented, especially from the storage target. You can imagine how complicated it is for an HBA provider to document their interoperability matrix, right? When that HBA has to work with every operating system you can think of, it has to work with just about every switch and target and backup device and management tool. It just a lot goes into interoperability. So it's a quite complex problem. And so, we track it, and we have, we draw graphs and we show, a certain test and how we're progressing toward a plan that has been broken down into a number of tests, and are those tests passing? If tests aren't passing, there's resolution and triage that goes on to address the problem. But, at the end of the day, we want to get 100% coverage. We want to get 100% success. And sometimes when things don't pass, you see that there's an exception to the interoperability, or sometimes it's written down as a compatibility, right? It's not an interoperability problem. It's a feature or function that isn't compatible, so it has to be either reconfigured or turned off. Just one example of a storage array, right? A storage array today, a modern storage array, has to operate with every operating system that you can think of, and it has to be validated, right? So this is a very large lab, and not only is there one storage appliance, but there's the flash version, there's the what are called the nearline or the slower disk version, so they're all operating on a fabric, right? And they all have to interoperate, and the drivers have to be up to date, and the multipathing has to work, and the tools that run on these operating systems have to work. So very large matrix, and this is just one dimension, right? This is just one storage appliance. And I was talking about compatibility, right? So there are many features. There is innovation in the industry, the shoulds, and many opportunities exist for creating value, extra value by any supplier in their solution. I'll just pick one example off this list. Dynamic buffer-to-buffer credit recovery, right? It's in the standard. There are some very strict shoulds and shalls in terms of how to negotiate, but the point is it's a negotiated function. If you don't want to participate, you don't have to participate. If a device will advertise, I want to participate, if the other device says, I do too, then you participate in this link level buffer-to-buffer credit. Sort of the underpinning of the resiliency and the stability and the data integrity of Fibre Channel is this use of buffer-to-buffer credit at the link level, right, which avoids problems of overrun and underrun. But sometimes, if there are problems, you have what's called lost credits, because there's a signal that has to go between the devices. I give you a packet, you send me back and say, okay, I got the packet already. And so you're counting, I can send you 32 things. Oh, you sent me 32 things, I'll send 32 more when I want them, right? So you have that flow control mechanism. Sometimes if things get lost, you need to resynchronize. And there's a standard that was defined that explains how to do this, but there have been certain corner cases in that standard that have surfaced, and some vendors have provided unique solutions to some of those corner cases. Again, they've innovated, and their solutions can be claimed to be more robust than others, and so you have this mechanism for differentiation. I call it innovation. Some folks will implement, another example is data integrity, a higher level of data integrity, right? Not only across the wire, as Fibre Channel provides data integrity across the wire, but now maybe I want to have data integrity until the data gets on the storage device, right? So there's a T10 and since Fibre Channel can support the transport of SCSI frames and SCSI capabilities. T10 diff and disk are a capability that can have a higher level of data integrity added to your storage solution, right? So again, you can build on Fibre Channel. You can use its capabilities to add unique value. So to you, the community, I think you need to hold all of your Fibre Channel providers to the standards, right? They're published interoperability matrices. We want the community, the Fibre Channel industry, to be held to a high standard. We write standards, we publish standards. I'm part of the standards committee for T11 3 and 2. And you know, we want to be challenged, right? We put our documents out for public review. We allow the industry who develops the standards to also critique the standards, to provide that feedback, to provide perspective on what should and shall be done, right? And so the FCIA, as a marketing organization, is constantly looking for feedback from the industry and providing events where we can not only talk about our new capabilities, but talk to customers about how we might be more innovative from a standards perspective. Just wanted to point out that the next speed, 64 GFC, is in final standards comment resolution. The standard is available for public review. If anybody cares to take a look at what's coming, it can be seen. The point being, you know, 32 gig fiber's been out for a while now. It's hard to believe, for 2 years and available. And now, you know, next year you're going to start to see 64 gig Fibre Channel solutions becoming available. But again, you know, standards get written, standards get reviewed. They go through a very rigid review process. So they become available for public review before Insights makes them a national standard. And that's where we are in 5.7. So just as a quick summary, I think I'm right on time. You know, Fibre Channel's been around a while. It continues to be a layered standard. It's multi-generational and interoperable and compatible, right? The shalls and the shoulds, right? We have unique functions. It's innovative. It's an in-order lossless fabric. You know, today we're hearing about Ethernet lossless fabrics, right? Well, Fibre Channel's been lossless from the beginning, right? We're not just today inventing it. We're not just today trying to figure out, you know, how complex it is to configure. It's straightforward to configure on Fibre Channel. It's flexible, right? We can incorporate NVMe, right? It's been incorporated, NVMe 1, and now it's being enhanced so that it has more resiliency. It has a higher level ability to recover from, you know, events, things that fail in time. It's scalable, right? You can build very large fabrics. It's resilient. It's an innovative platform. It's trusted. It's rock solid. Built-in data integrity, built-in security, predictable for you in terms of performance. There are long distance. There are disaster recovery solutions. And as I mentioned, it's future-proof, right? The old speed and the new speed will interoperate. They will negotiate the link. And with that, Mr. Rogers, back to you.
Thank you, Barry. Thank you, Tim. I do have a question on the board here. Let me point out to you folks that if you have any questions, please go ahead and put them in, and we'll get them addressed with Tim and Barry here. A couple things we'd like to point out. We have ongoing webcasts, and one of the questions was you know, how to find more information about things like Plugfest and how to participate, when they're going to happen. the Fibre Channel Industry Association, or fibrechannel.org, is a fantastic place to find information about what we're doing in the industry and about these upcoming events. To participate in a Plugfest, and I posted some information on the presenter to audience announcement section here earlier, go to the Fibre Channel Industry Association website, fibrechannel.org, and look up the Plugfests, and there's a page on there that will tell you about the ones that we've already had and when we're planning the next ones upcoming, and you can register and participate that way. If you're on the reflector and you're getting information, then we will be able to send that out on the mailing list. So feel free to sign up if you aren't already a member in that way. Our next webcast will be on the 10th of October at 10 a.m. West Coast time, same bat channel. And I think we have it added in here, don't we, Diane? There we go. So this will be our next webcast. We'll be having discussions about how some of these interoperability matrices and tests that Tim and Barry have alluded to are actually performed, what to look for at layer 0 versus layer 4. So it'll be a follow-on with a little more detail on some of the tools and the applications that are used to do these kinds of testings, and that you can recreate in your own environments as well. So with that, we'll open the floor to any questions, or if anybody has any follow-on comments, Tim or Barry, if there's something else that you thought about, please go ahead and share that at this point.
Well, Dave, as you know...
Okay, we got some feedback here. Oh, go ahead, Barry. You go ahead, Barry, while I'm looking up the feedback.
I was just going to say that, there's so much here that we could drill down on. We could spend a whole session just talking about layer 0, right? So we tried to just cut through it here, give you a high-level perspective, and reinforce the message from the FCIA that, rock-solid technology, and this is why.
Yeah, I think from our perspective, you could take a week-long course to scratch the surface again, to get as deep as you wanted to, but FCIA has definitely positioned itself well for newer technologies that are coming down the road, such as NVMe and things. So, nice job, industry.
Yeah, as you guys were presenting and I'm listening, I'm thinking about this from the tools perspective and going, boy, there's just so many different things we could add in here. It is definitely a big can of worms, but thankfully, folks like you two have put together test routines and matrices and put together these test arcs that help solidify the interoperability challenge that we've discussed today. So I don't have any more questions coming in just yet. I will give you guys, we have 3 5-stars and 1 4-star. I'd like to know who only gave you 4 stars on this, because it was an absolute excellent session. So got another, okay, we have a question. Go ahead.
I wanted to just mention that if anybody wanted to read a detailed procedural test plan, the IOL on their website does a very nice job of step-by-step explaining how a test is executed. And so it can be very informative to anybody who wants to kind of understand how this operation of doing interoperable test is laid out, and how it's very meticulously spelled out, documented, and scored in terms of observability. So please take a look at the IOL's webpage. I'm sorry, Dave, go ahead.
No, it's an excellent point. It's not a marketing checklist item. It's an in-depth industry imperative that we do these kinds of things. So
absolutely,
the test plans that are derived for these are specific to the challenges that we're facing at the time in the industry. So we have multiples over the course of a year, and it's nice to be able to put it on your materials, your literature, and say, yes, we're conforming to the specification, but this kind of hands-on, and might I add, quite friendly. You consider you've got competitors in the industry that come together. We're all there for a common goal, which is to ensure that the products will work when our customers the customers in the field buy these things and bolt them together and don't have a dissatisfactory user experience. So one of the questions we have here on the board is, do we expect any FC-NVMe versus Rocky performance comparisons in the future? I suspect that you would probably find a couple of companies or organizations that would put together a, this versus that kind of scenario. The Plugfest doesn't typically come out with this is faster, better, or quicker than, one technology is faster, better than another. We go to presenting the technologies that they're compliant and that all the vendors in the ecosystem are supporting these based on specification and testing. I would not be surprised to find somebody who's got both of those in their bailiwick to do a performance or comparison. I don't believe that the FCIA has anything planned at this point in time, but we'll keep that as something in our educational quiver to maybe pull out later on. And we've got more. Now we have all 7 reviews came back, or excuse me, 6 of the 7 reviews came back with 5 stars, gentlemen. So I say good job to you both. Again, let me see if we have it in here. We should have do we have the contact slide in here? No.
No.
Go back to, so fibrechannel.org. Remember, the fibrechannel.org is the gateway to FCIA, and then everything else behind that. We'll have our October 10th at 10 a.m. next webinar. Please look forward to that. And if there's no other questions or considerations from our speakers, I will bid you all adieu and thank you for participating. This webcast will be available on the Bright Talk FCIA page for future use.
Thank you, everybody.
Thank you, David.
Thanks, Tim. Thanks, Barry. Thanks to all of our audience. And you guys be well. Bye-bye.